Hey everyone, this is Mr. Patel talking to you for Sports Exercise Health Science. And this is our second part on nutrition, focusing on the macronutrient carbohydrates. And so if you want to follow along in your assessment statements, this is going to be mostly dealing with 3.1.3 and 3.1.5. So let's think here for a minute. Do you know what carbohydrates are and where they come from? What do they do? What are they made of? And how are they different amongst, even though we think about all carbohydrates being the same, they're actually, when you start breaking them down, they're very, very different. So let's begin here. It looks so good. All of this looks yummy. I mean, these little muffins over here, these rolls, and you got all this wheat and breakfast cereal and bread. It's the great stuff. We all crave this stuff. It's everything that is something, well, it's all really, really important, but in moderation, right? So carbohydrates are synthesized by plants from two things, water and carbon dioxide. And of course, that requires sun energy, right? So think back to your 8th grade and 9th grade biology days. And if you know what carbohydrates are, they're made up of 3 various elements from the periodic table of elements. They are, say them to yourself, that's correct, they are carbohydrates. Carbohydrates are made of carbon, hydrogen, and oxygen. Those are the only 3 elements that make up a carb. And they are specifically in a 1:2:1 ratio of carbon, hydrogen, and oxygen. And if we think about the function here, folks, the carbohydrate serves an important function related to energy metabolism, and it's really a fuel source, right? We store it in our muscle and our liver, and eventually it can be converted and stored as a fat. And there's a trick to identify carbohydrates when you're looking at words. If the word ends in OSE, then it's going to be a carbohydrate of some type. So, great example, the example we always use is glucose, right? GLUCOSE. Ends in OSE, which means more than likely it is a sugar or a carbohydrate. So, speaking of the glucose molecule, here it is, back to chemistry class. If you were to count all the carbons, and sometimes these C's are not here, they're just little joints. The little joint is an implied C. Of course, oxygens. You'll notice here that there are 6 carbons, 12 hydrogens, and 6 oxygens. Again, a 1:2:1 ratio. And what happens here is on the glucose molecule, you'll notice that this is a little OH right here. The glucose molecule typically binds with another molecule. So this is called a monosaccharide, one single sugar. And it's the simplest form, easily absorbed by the body. And we have 3 different types here, actually called glucose, fructose, and galactose. But we'll get to that in a second. But sometimes if we want to combine them, we have to use this little chemical process called condensation reactions. So this is a condensation reaction. To combine a monosaccharide with another monosaccharide over here, we have to bind these elements to stick them together like glue. So the reason why it's called a condensation reaction is when you combine these two, notice we're combining the OH and H. Well, if you put that together, what do you get? Think about it. Think about it. H2O. Exactly. You get water. Hence, condensation. Think about condensation on the side of your cup if it's a cold soft drink, or on your windshield when you're on a cold winter morning, you have condensation. So a condensation reaction is where you are producing water because two things have been combined. Okay, what's the opposite of a condensation reaction? What if I wanted to break this really complex sugar? This is not a complex sugar, but bear with me for a second. If this was a mega sugar with polysaccharide and had just tons and tons of sugars put together, if I wanted to break it up, I'm going to actually introduce water, and the water that's introduced is known as hydrolysis. Hydro meaning water, lysis meaning break. So we use water to destroy the bonds that have been created here, and then we end up with these two independent molecules again. Okay, so glucose plus fructose actually makes sucrose, which is known as table sugar, what you put in your coffee and your food and your cereal every day. So a condensation is the linking of a monosaccharide to another monosaccharide, or perhaps even a disaccharide, or perhaps even a polysaccharide, by the removal of a water molecule. Okay, so let's take a moment to talk about monosaccharides, disaccharides, oligosaccharides, and polysaccharides. So I think I've told you this before, that the monosaccharide is the simplest form and is made of one molecule, very easily absorbed by the human body, and our examples are, as you can see, glucose, fructose comes from fruit, and galactose, typically dairy products, and storage. Disaccharides would be two monosaccharide forms, disaccharides with the loss of one molecule of water, right? The condensation reaction. And I gave you the example of a fructose and a glucose combining to make table sugar. An oligosaccharide is going to be 3 to 9 molecules, and it could be any combination. But an example here will be maltodextrin, and we'll talk a little bit about that later on. Actually, you might want to pause the video here and search what maltodextrin is, and I'll leave that up to you to determine what that means. Okay. The next one is the most complex, and so the polysaccharide are long chains, typically longer than 10, and we could talk about starch, we could talk about glycogen, we could even talk about fiber here. So we've broken it up into these big categories of plant polys and animal polys. So remember, if it's I'm going to backtrack here for a minute and talk about the di, oligo, and polysaccharides. Those three have got to be broken down to the simplest form, the monosaccharide, so that our intestines, stomach, large and small intestines, can absorb the nutrient and then transport it to the necessary cells or organs that need it. So some of those oligo and polysaccharides are indigestible or poorly digestible, and we call that fiber. It's dietary fiber. Dietary fiber is mostly found in the cell walls of a plant, if you think back to biology class. When you have that cell wall in that square cell, that creates cellulose. And really, really important part, like fiber is a really important part of prevention of diseases because it's cleaning out your gut on a regular basis. So insoluble fiber right there. Let's think here. Oh, and then starches. So starches are going to be your complex carbs. These are going to be seeds, grains, corn. We get tons of starch from like potatoes, sweet potatoes even. And then the glycogen is stored sugars, and we'll talk a little bit about glucogenesis. Genesis meaning the creation of, gluco would be sugar. All right, so you're going to see here some visual examples. And remember, a ring structure like this with carbon, hydrogen, and oxygen, this whole thing, C6H12O6, this is a monosaccharide. And you notice that all of these are identical. They have connected in the same manner, where the CH2H2 is all at the top.